Alright, for the rules of complement. Alright, so this is the discussion. Continuation with the addition law or the addition rule, okay, of probabilities. Okay, so this one is for the rule of complement or the rule of the otherwise. Alright, let's get started. Okay, so given an event A from the sample space S, the probability that A will not occur is the probability of that A is equal to 1 minus P of A. Now we know that the total probability of everything within the sample space is 1, or the probability of the whole sample space is equals to 1. Okay, this means that if we're trying to find out things that is not of that event, okay, we just need to subtract that event or the probability of that event from the total probability, which is 1. Okay, so in other words, the probability or A complement of A complement or A of A complement, okay, or A prime is equals to 1 minus P of A. In other words, if this is A, no, everything that is in the color violet is not A. Okay, so that is not A. Okay, so that is why the probability of not A is the violet, which is 1, the total probability, and then minus the probability of A. Alright, so in recent year, there were 3 million skydiving jumps and 21 of them resulted in death. Find the probability of not dying when making a sky jump. Okay, so the probability of not dying is 1 minus the probability of dying in skydiving. Okay, so that is what? Total of 1 minus 21 over 3 million. Okay, so that is the probability of happening when you dying in skydiving, 21 out of 3 million jumps. Okay, so that is 0.9993. Okay, so yan. Okay, so later on we'll be doing some exercises for this. Okay, just like what we did in the class, so that you can have some um, ways to answer them. Alright, so from the Venn diagram, the probability of the entire sample space can actually be expressed as, okay, so like this. Okay. Alright, so I'll be cutting it here. I think I can do for contingency table already. Okay, so contingency tables, okay, is a summary of counts of elements that belong to 2 or more categories. Okay, so this is an example of a contingency table. Okay, for instance, the marketing department at the Rola Cola bottling company is investigating the attitudes and preferences of consumers toward Rola Cola and the competing soft drink Coca-Cola. Okay, 40 randomly selected shoppers are given a blind test and are asked to give their cola and their sweetness preferences. Here are the results. Okay, so for Coca-Cola and Rola Cola, okay, so weird names. Anyways, let's divide them accordingly. So for in total, okay, you have 40 in all of them. Okay, now we have 4 that is very sweet. Okay, and then Rola Cola sweet and not so sweet, a total of 13. Okay, so totaling of them, everything in terms of probability, we divide everything by 40. Okay, so because they are all collectively part of a probability. Okay, so as you can see it here. Okay, so yan. Okay, so let's ask some question. So what is the probability that, okay, what is the probability that um, a shopper would prefer, this is red or blue, prefer um, a very sweet Rola Cola. So very sweet Ito yung very sweet. Okay, and then Rola Cola, which is this one. So the intersection will be this. Therefore, the answer is 8 over 40. Okay. What if they prefer, okay, what if they prefer not so sweet at all? Okay. What is the probability that that the shopper would prefer, okay, not so sweet? Okay. So, not so sweet, it didn't mention either Rola Cola or anything. So, this is the not so sweet. Or, you just add them together. Okay. So, this is not uh, shopper prefers not so sweet. Okay. So, what if what is the probability that the user prefers Coca-Cola? Okay, prefers Coca-Cola. So, ito yun. Okay. But, if the user, what is the what is the probability that a shopper will prefer a sweet, a sweet Coca-Cola? Okay. So, that will be this one. Sweet Coca-Cola, or sweet and then Coca-Cola. Okay. Yep. Alright. So, let's try another example. Let's try something that we can solve. A sample of 500 respondents in a large metropolitan area was selected to study consumer behavior. So, we have a total of 500 respondents. Among them that were asked, do you enjoy shopping for clothing? Okay, of 240 males, a total of 240 males, we have what? 136 answered yes, and 260 females, 224 answered yes. Okay, so let's try to map it out. Okay, so we have uh, this enjoys shopping, and then this one is the gender, male, then female, then we have yes or no. Yes, tsaka no. Okay, so we have a total of 500. We have 240 males and 260 females. Okay, and upon the male, we have 136 that answered yes and 224 that answered no. Okay, so the deficiencies of the table we fill out. Okay, so we fill out. So where the hell? So we have 136 as 224 equals to 360. And we have, for the no, of course, we will what? Subtract 240 from 136, which is 104. And then we subtract 260, we need 224, which is 36. Okay, you can actually just subtract 360 with 500 to get them. Okay. That's 140. Okay, so we have this table already. Now, this is a contingency table already. Okay, so let's say we can get the probability, and already. Okay, so let's say you just divide everything by 500. Okay, so that will be the probability. So let's say, for example, what is the probability that the respondent is a male that did not enjoy clothing, shopping for clothing? So a male that did not enjoy or does not enjoy shopping for clothing. So this one is the answer. So that is 104 divided by 500. So male that does not enjoy shopping for clothing. Ah, yan. So, another is, let's say for example, we're trying to find out uh, what is the probability that um, a female does, that does not enjoy. So, ito lang yan. Okay. Of course, there will be more complicated things like this later on. We'll be constructing them. Okay, so um, I'm just actually collecting it in a while. So we'll be answering them in a while. Okay, so let's see. Where is my mouse? So a random of 200 adults. Sample of 200 adults are classified below sex and their level of education. So what is the probability that the male adult does not have college degree? So the answer is, okay. So ito lang siya. In totality, ganito lang yan, ha? So ganyan lang gawa ng contingency table. Of course, there will be times na magkakaroon ka ng third part. No, meron siya third part like C. No, later on, you will be doing that. That will be a little bit more complicated in a sense. Alright? So that's it. Okay. So let's have these exercises naman. Okay. So this one is a contingency table problem that we will be answering together with the other exercises. So this one will be the first that we'll be answering. And then we'll be answering a series of exercises after this. Okay? So that you can prepare for the um, quiz by Tuesday. Alright? Sige, I'll see you in a while again as I record a new one. Okay? Bye-bye.